Okay. So we've got accuracy and precision is what we're going to talk about. Do you understand, or do you get the idea between accuracy and precision? What do you think the difference between accuracy and precision is? Or have you always kind of thought of them as the same thing?
Accuracy is getting something like correct, and precision is doing it like carefully, and I don't know.
Okay.
That's my best.
Right?
I think precision is how specific you are.
Okay. Good. Yeah. So precision comes down a lot of times to how good you are at analyzing the whatever instrumentation you're working with, or how good that instrumentation is. So if I have a meter stick and it's just a meter, it's only, all I know is that this is a meter. It's not divided out at all. Okay. That versus a meter stick that's divided out into millimeters, just tiny little increments. I'm going to be much more precise with the meter stick that's divided out 1,000 times than I am with just the meter stick. Okay. So precision oftentimes goes back to how good your instrumentation is. And then accuracy is how close you are to a given specific amount. So there's standards out there. On the periodic table, we have different masses for different elements on there. How did they get those? What did they do to do that? Well, a bunch of people did it. They repeated it over and over again. Everybody got the same results. Those things are standards. So everybody has agreed that, yeah, this amount is the same for oxygen no matter where you go. There used to be, back in my day, I've got my cane out now and I'm walking around, a big, thick manual that had all of these standards in it. So when I was in school, we had to go back and find those values in that thick manual. Now all you have to do is go to Google, type it in, and it's right there. But back in the day, we had a kind of a standards book that we would have to look those values up in. So that's how we get accuracy. So, like I said, accuracy means, for me,
Press hide.
there we go. What's wrong?
Nothing.
Okay. Well, sometimes things don't look right up here and I'm right on top of them and I miss it and stuff. So
You can press the hide button.
yeah, but then I can't stop sharing because I can't get it back. I've run into that pitfall before, let me tell you. Anyway, so accuracy describes how close you are to a specific value, and precision refers to the degree of certainty that you have a known value or how close your values are clustered together. So you can see here that employee A, all of their answers are very closely clustered together. So they are very precise. The correct answer, though, was 6. They are not very accurate. So even though their values are all clustered together, very close together, they were not correct. It would be like taking a test, and 4 of you come up with one answer, but it's still wrong because you didn't come up with the right answer. Does that make sense? B is just a hot mess. They are not precise or accurate. Okay. Their answers aren't close together. Their answers are not even close to this value. Well, this one's right on, but they're not very, yeah. And then this guy, he's pretty good. He's got all of his answers. They're clustered pretty close together, and they are, they're close to that accepted value. Okay, makes sense? Values. Oh, this is not the right computer. Okay, so there's actually a way to measure your percent error and your percent yield. These will determine how close your measurements are to those accepted values. So for percent error, Notice that for percent error, you have these bars here. Those bars indicate absolute value. That means that you are determining your distance from zero. So for percent error is never negative. And that is because of these bars here. These mean absolute value. So distance from zero. You want your percent error ideally to be zero because you want your accepted value and your experimental value to be the same. And if they're the same, this minus this is going to be zero. And then this 0 divided by this will still be 0. So ideally, you want 0% error. If you can pull that off, you've done a really good job. In college, typically with our labs, we would have to calculate our %0. And in a lot of cases, our percent error. And in a lot of cases, if we were above 5% error, we'd have to go back and redo the lab. Percent yield then will end up being, this is not going to be negative either. Okay. But typically you won't end up with that as an answer. Here though, you ideally want this to be 100%. Because that means that you got out of your experiment the same amount that you were supposed to have. Because if you do this divided by this, if this is the same value times 100, it's going to be 100% error or percent yield. You will sometimes end up with a number greater than 100 for this answer. Okay, but these are two ways that you can determine the accuracy of a experiment. Good? Pretty cool with that?
Yep.
Okay. Make sure when you are calculating this percent error here, this is one of the pitfalls that people fall into and they get the wrong answer. Okay. Your calculator runs by something called order of operations. Okay. So that means order of operations, they have some sort of acronym for that. PEMDAS or something. Okay. Parentheses for all that stuff. Okay. But the point is that division is going to happen before subtraction. And in this case, you don't want that to happen. So you want to do your subtraction first. You're going to hit the equals key on your calculator. Then you hit the divide key to go and divide by this value. Okay. If you don't do that, it's going to divide this guy by this guy, which is, well, it'd be 1, because this divided by this would be 1. And then it's going to go and subtract from here. Okay. So be careful with that, because that is a very common error that people do just by not hitting that equals sign. Okay. So precision then can be measured using the percent difference for your values. You're going to calculate the mean. What is another easier word for mean to think of? Average. Okay. So if you need to do this, take average. Sometimes it's easier for you to remember that. It is for me anyway. I can never remember the difference between mean and mode, and there's a bunch of different ones. And so they all start with M, and I'm like, which one's that? Yeah. So calculate the average. Calculate the average difference from that mean. Find the difference from the mean for each, and then take the mean of that set. Divide the average difference by the mean, and then multiply by 100. This sounds really complicated. It's not that bad. Let me take you through a couple examples, okay, before you Don't check out on me. Don't drop my class. It's okay. All right. So we're going to go back into a percent yield here, and then I'll do one of those other examples with you. All right, percent yield done is the theoretical. So in theory, you should have this amount, and this is your experimental. So this is your experimental, and this is your theoretical. Okay, and this is experimental divided by theoretical times 100. So I've got 1.96 divided by 1.92 times 100. So if you calculate that out, you should end up with 102% yield. So you actually did better than theoretical. And sometimes that's the case. You probably did something wrong in your experiment because you really shouldn't create more than you started with, but something went wrong. But ideally, you got a lot of stuff made. Okay. Good. Questions on that one? Easy enough to do? That's the easy one. I think this one is calculate the density, calculate the percent error. Okay, so this is percent error. Okay, so density, we need to talk about that formula because I don't think that I've introduced that one to you yet. It's really easy to remember. It is log. Density equals log. Are you in love with density? Yeah, I know, I'm crazy. If you divide this out, which you have to do to find density, you can think of this top line as being an M. So mass divided by, and what letter is that? A V, volume. So that's how you remember the density formula. Well, now for your quizzes, for your tests, I give you that formula so you don't have to have it memorized. But, in a way, it's kind of easier just to have it memorized because then you don't have to keep looking it up. So if you get it ingrained in there, it works, but you don't have to. So don't stress over that. Okay. These calculations, the percent yield, percent error, I give you those formulas too. So you don't have to memorize any of the formulas. You just need to know how to use them. Okay. All right. So calculate the density of the penny. So we have a penny is 2.5 grams and the volume is 0.35 milliliters. So I'm going to calculate density is going to equal my mass, which they gave me as 2.5 grams, divided by the volume, which is 0.35 milliliters. I'm going to punch that into my calculator. And I end up with 7.1. And then we need to talk about units. I'll let you write that down, and then we're going to talk about units. This is 7.1. None of my units divided out. So I just take these units right here, and I just bring them over here. So the units for this are grams per milliliter. If I put them in my problem, then I can figure out what the units on my work, on my answer is going to be. Don't be lazy. I know you want to be lazy and not put those units down, but they will help you Trust me on this one. All right. So I've got this as the density of this penny. They want us now to do, so this was number 1. Number 2, they want us to do a percent error for the penny. So remember that that is the accepted value minus the experimental value, absolute value of that. If it's a negative, we ignore the negative, divided by accepted times 100. So I'm going to go through and I'm going to sub in my values. My accepted value, they told me, was right here. So I'm going to bring that down. So that is 8.96 minus what we got in our experiment, which is 7.1. And then I'm going to divide by my accepted value again and multiply by 100. Now, I want you to do this on your calculator because I want to make sure that you are doing it the right way. So take a minute. Remember what I said after you get done with that top line. What do you need to do? Were you able to get 20.8 for your answer? Good. If you didn't, you probably did not hit the equals key after you got done with the top line. So remember, you want to subtract equals, hit your divide, and divide by the next number. Anybody have trouble getting that when you want me to come around and help you? Yeah, and then you have to multiply by 100.
Thank you.
Good? Yep. Great. Okay, so those are the easier ones. You will have ones like this on your test and on your quiz. Okay, I'm going to show you the precision one, but you're going to have a couple of those in your homework, but they're not going to be on a test or a quiz. Okay, I want to expose you to it so that if you ever see it again, like in college, you're like, where did that come from? You can go, oh yeah, I remember Lippy that one day. This seems a little familiar to me, but I'm not going to be testing you on it. So don't get too worked up about this one. Okay. If you're like, I have no idea what she's doing. Okay. Just get through the homework and you'll be fine with this one. Everything else that I've covered is going to be on test. Okay. All right. We have the average height here given, and then they want to calculate the percent difference. So first of all, we're going to start out, we're going to average these together. So add these together and divide by 3. So that is step 1. Everybody okay with that one? Were you able to get 174? All right. Now you're going to take each of these values and you're going to subtract from this, the absolute value of it. So I'm going to take 174 minus this, 174 minus this, and this minus 174. That's what we're going to put in this column. So this one you can probably do in your head, I hope. That makes sense where I got that number from, how I got it. All right. Now I'm going to take the average of these and put that down here. So add 4, 5.8, and 9.7 together and get the average for this box. All right. Now, last step, we're going to take this value, divide it by this, and multiply by 100. So we're going to take 6.5 divided by 174 times 100. You should have gotten 3.7%. Ideally, you want this to be 0. But you can't help how somebody grows. Especially now that we've got decent nutrition. All right, so those are your we do problems. You have, I think, how much time do we have in here? Advisory 33. So you've got quite a bit of time to be able to get all of your homework done. So you've got the you do for this section to finish up. And then if you have a moment and you've got somebody in here that you're like, I really want to be that person's lab partner, come up and talk to me about it. Otherwise, I'll eventually just pair you up and be done with it. But if there's somebody in here that you're like, oh, they're my bestie, I want to work with them. Or, hey, I get along with this person. Then come up and talk to me and I can get you guys started to pair up. So, okay.